All right, guys. So, guys, so we are looking at the next section. Actually, it's the next two sections. I combined them because it's still really short. The book separates them really small. So I also handed out the green formula sheets. So that green sheet you will be able to use on your test. You'll get to use it on your final exam for the class, so don't lose it. Okay? If you look at it, though, you have the different boxes on there. I told you we had 6 formulas. We've already done simple interest, so we did one on top. We're going to do APY and then the compound interest today. So these are the two we're going to focus on. Compound interest, notice I kind of added another name underneath there. Future value of single deposit investment, because if you look beside there, there's future value of periodic deposit. That way you can compare. That's kind of one's a single, one's a periodic, and then you have other formulas at the bottom. But we'll spend lots of time working through the formulas nice and slow and going through everything with you, okay? All right, so compound interest is money earned on the money that you deposit plus any previous interest. So a lot of you guys on that one homework question, when I was asking like each year how much interest did they earn, simple interest is always the same no matter what, because it's only earning interest on that very first deposit. Compound interest takes the interest you've earned and puts it back on top, so your principal gets bigger. Earns more interest, adds it on, your principal gets bigger. So then it's earning interest on a larger amount every time. So compound interest, much better. And that's the other note I put on there. Just simple interest, only the original principal is used to compute the annual. So simple interest every year, every time you calculate, it's always the same, over and over and over again. Even if it's in there 50 years, you're never going to earn any more per year. Compound, though, keeps adding it on, so that principal gets bigger. The principal gets bigger every time, you earn more and more interest. Does that make sense? You okay? All right. Interest can be compounded at different intervals. So simple interest we always just talk about for the year, and we can do it annually, but we can also compound it semi-annually, quarterly, daily. What that means is when it's compounded, it's how often the interest is added back to the principal. And that principal grows every time the interest gets added on. So if it's annually, then that means once a year, it's going to take all the interest you've earned, put it on the principal, and then the principal changes. And then for the next year, it would go off of that bigger principal. If I did it semi-annually, how many times is semi-annually? That's twice a year. So annually is 1 time per year. Semi-annually is 2 times per year. So if that's the case, then they would take like 6 months. Then they would say, okay, how much interest did you earn? They would add it onto that principal amount, and then for the next 6 months, it would be on a larger amount, so you'd earn more interest. Then after that 6 months, they'd take all the interest, add it back on, and then it would get even higher. Every 6 months, that would get higher. All right, we can do quarterly. How many times is that? That is 4 times per year. Good. Daily is 365 times per year. Which would be fantastic, right? Then every day that principal amount it's earning on would get bigger every single day. Probably. Monthly also can show up. Monthly we know is 12 times per year. All right. We also need to talk about annual percentage rates and annual percentage yield. 2 very different things. So annual percentage rate, APR, is the interest rate paid or charged, if it's a loan, per year. So that's per year, just like time is always in years. This is annual percentage rate, so it is for the year. So if you guys think about credit cards, anybody have a credit card? A couple of you? Not debit, but like a credit card. A couple of you do? What kind of interest rates do credit cards usually have? Would you say unfair? They're usually really high. 18. So usually, like credit cards, you may see like, especially if you're new getting a credit card and your credit score is not great, you're probably looking at like a 25 to 28% interest rate, which is insanely high, right? But that annual percentage rate doesn't mean that every month they're charging you 28%. What's 28 divided by 12? That's the rate they're charging you every month. right? That's for the year. So then you'd have to kind of divvy that up by the month. And we'll talk more about that a little bit. But annual percentage yield, this is always something I remember, like when I was younger, like I would hear this, I'm like APR and APY, I'm like, I don't understand the difference. Annual percentage yield, sorry, it's a lot of words. It's the simple interest rate that would be required to give you the same amount of money that compounding does. So compounding, right, keeps that principal amount gets bigger and bigger every time, right? So you keep earning more and more interest as time goes on. So this annual percentage yield is what would be the simple interest rate that would make the same amount of money in the same amount of time. So if I didn't keep making that principal bigger, this is the rate you would have for simple interest to get the same amount of money. So what do you think? Is the APY going to be higher or lower than the APR? The APY will be higher or lower? Higher. Simple interest, you'd have to have a higher rate to get the same amount of money as you would if it was compounding all the time, right? Because simple interest, just initial amount. That's all it ever earns money on, just that initial deposit. Compounding, it gets bigger every time you compound, so you earn more and more interest. So this rate will always be higher than your APR. So simple interest earn the same amount of money, it's going to have to be a higher interest rate. Okay? Now, look at your formula sheet. Do you see a formula for that on there? Yeah, there's a formula. How easy should it be to recognize when I'm asking you for the APY, what formula to use? Yeah. If I say, what is the APY? You use the APY formula. If I don't ask you for the annual percentage yield or the APY, you don't use that formula. So it's just like simple interest. That one should be easy to recognize. All right. The other formula is compound interest, or I changed the wording on there also as a future value of a single deposit. This is your formula. Isn't it pretty? Are you good? Okay. All right, so your formula, I need you guys to start recognizing kind of what different letters are. Capital B is your ending balance. So this time, this formula is solving for the complete balance in my account. What was our last formula solving for? Just the interest. So if I asked you for the total balance at the end, you had to add it back onto that principal amount. Will I have to on this one? No. If I ask for the total balance, that's what it's going to give me. But if I ask you for interest, you're going to have to subtract the original amount off of this to find the interest. Okay, so you got to be careful. This one talks about your balance, the very total balance at the end. Simple interest is just the interest you earned. Right? So P, again, stands for your principal, or the original amount you started with. R is still your rate as a decimal. The new variable here, because T is still a number of years, is N. N stands for the number of times it is compounded per year. So if I tell you it's compounded monthly, how many times per year is that? It'd be 12. It's compounded quarterly. It'd be 4. So you have to kind of look for those words in there. All right, so let's try a couple. Marie deposits $1,650 for 3 years at 3% interest, compounded daily. What is her ending balance? Okay, so take a look. This is talking, do you see the word simple interest anywhere? So am I going to use the simple interest formula? No. All right, it is compounded daily. So you literally see the words compounded right in there. So the problem we get to looking forward into like the next sections, people usually are okay, simple interest for the most part. APY is an easy one to tell. It's these bottom 4 that people get confused on because they're similar. So if you look, the one that we're working on is talking about her ending balance I'm trying to solve for, right? What is her ending balance? So if you look at the formula next to it, also is B equals. So both of those formulas will give you the ending balance pretty easily. Now the difference between future value of a single and future value of a periodic. How many times is she depositing the $1,650 bucks? How many times is she putting money into her account? Once. I want to know, it's compounded daily, but how many times did she put money in? Just one time. She is just putting that money in once. And everything we talk about is going to be once today. but I need you to see the difference between these two formulas. The other one next to that is periodic. That would be if she was putting 1650 in like every month, like constantly putting money in. So obviously that's going to grow a lot faster. This is, she's just putting in the money once and just letting it sit there and see what she gets. All right, so let's go ahead and go through our formula. So we have B equals, the principal is 1650, parenthesis, 1 plus 0.03 over n is how many times is it being compounded? Good. Daily is 365. Close parenthesis, and then it's n again. So it's 365 times 3. Yes, that is an exponent. Now, if you were using the graphing calculators, I think they are the easiest ones to use to do these problems. Absolutely the easiest. Does anybody use a scientific one on a regular basis? Haley does. All right, Harley does. If you're using the scientific one, for you guys, the big kicker is going to be, you have to tell me what this is. So it's just one number as an exponent. Don't put it in as 365 times 3. Your calculator's going to do order of operations. It's not what you're going to want. Okay? If you're using scientific, that's about the biggest change is right there. If you're using the graphing ones, you can literally type it in just like this. And I want you all to practice because this is not hard, but if you type it in wrong, it's going to give you a wrong answer. You know what I'm saying? So, guys, when I'm typing this, exponent is on the outside of the parenthesis. So 1650 parenthesis 1 plus, to get the fraction, it is the alpha button, which is green, and then hit the y equals button. That would give, if you want the fraction button, because we're going to have to get fractions as we go further into this. Look at all of your formulas. You're going to need a fraction button. And this one you could. Okay, but that's your fraction button. Or on this case, you can divide, but as we get into further formulas, you're not going to be able to just hit divide. Make sure you close your parenthesis. Again, with the graphing ones, if you hit the caret button for your exponent, it's going to allow you to just type in whatever you want, and it stays up as an exponent, so it makes it nice. So $1,805.38. If you did not get that, guys, I need you all to try this because the calculator is going to be your best friend or your worst enemy. All right, number 2. Kate deposits $2,350 in an account that earns interest at a rate of 3.1% compounded monthly. What is her ending balance after 5 years? So compounded monthly. Again, do we recognize that she is only depositing money one time? Okay, she's putting in that amount of money, and it doesn't say she's putting it in every month. She's just putting it in once. I know what's coming in the future, so I want you to start to recognize that. All right, so B equals, my principal is the $2,350, parenthesis, 1 plus my rate, the 0.031, compounded monthly, so what's your end value? It's 12. And then it's 12 times the time, and this said 5 years. Now, guys, here's going to be my suggestion you're probably not going to be happy about. I want you to write the formula down. Like what I just wrote right here, I would want to see that, and then I want to see your answer. Because if I'm grading a test and all I have is an answer and you typed it in wrong, do you know what I mean? Like we have 6 formulas. So come test time, I need to know, did you just accidentally type something wrong or did you just use the wrong formula? Do you know what I mean? Like that makes a big difference if you knew the formula or not. All right, so we should get a balance. Very good. So $2,743.45. Guys, again, practice this. I've seen students are like, yeah, this is easy, and then they can't use the buttons on their own calculator. Okay, I need to make sure you know how to do this. What? Oh, that's wrong. All Number 3, you guys ready? So Riley invested $13,482 at 2.6% compounded hourly for 6 years. What is her ending balance? How much interest did she earn? So real quick, guys, the compounded is how many times per year. So how many hours are in a year? How many hours are in a day? 24 in a day. Times how many days are in a year? 365. All right, so hourly would actually be 8,760 times. That's your end value. So anytime it's talking about how much is compounded, it's per year. So you always have to kind of look at that for the year. All right, so writing in your formula, the principal, 13,482, parentheses, 1 plus my rate, 0.026, compounded would be 8,760. I know, 8,760, and then years was 6. So go ahead and type that in. Give everybody a minute to type in. Yeah, it just takes longer to type it in than anything else. So she gets an ending balance of $15,758.11. Now, guys, did I answer the question? I answered one of them. Question said, what is her ending balance? Okay, got that. Now, here's where people mess up. Okay, people look at that and they read, how much interest did she earn? Oh, that's simple interest. And then they've used that formula. Did it say simple interest? No, it didn't say simple interest. If she started with 13,482 and now she has 15,758, how much did she earn? Just subtract them. Yeah, all you have to do is subtract. Don't jump to another formula because it asks for interest. Use your brain. It did not say simple. Type it in. When is the only time you use a simple interest formula? When it says simple interest. My board glitches sometimes. There was a space for it. I wrote it. It just didn't. Yeah. Thank you. It was interesting. There you go. All right. Are we okay, though, on how to find the interest? You just got to subtract the original amount. Yeah, a lot of this chapter is. If you can recognize which one to plug it into. All right. And then the other part, real quick, was the annual percentage yield. So this is the interest rate I need in order to earn the same amount of money with simple interest as I would using compound. So this is going to be higher, right? So there's a formula, and we, again, just plug stuff in. So you have an R and an N. It's the only variables you have. All right, so Sharon deposits $8,000 in a one-year CD at 3.2% interest compounded daily. What is Sharon's annual percentage yield to the nearest hundredth of a percent? So again, for this, how easy should it be to recognize the formula? What is her annual percentage yield? So I'm going to go to the APY formula. 1 plus my rate is 0.032 over N. What's my N? Daily. So that's 365. N again, so 365 minus 1. Did I even need to know how much money she was putting in? Nope. That was irrelevant. The formula didn't ask for that. So we just type it in. Again, practice typing these in, guys. Let's make sure we're okay with the calculators. If you're using the graphing ones, when you hit that -1, make sure it's not up there as an exponent. Make sure you've aired it back down. So we get an APY of 0.03. Now, what's the nearest hundredth of a percent? So I need you to be careful. Is that a percent right now? That's the percent of the decimal. So what percentage is that? That is 3.25%. So when it says nearest hundredth, I actually have to go beyond that when I'm writing my decimal down because I need to move that back to an actual percentage. Move it back or multiply it by 100. That helps you out. Right? So whatever answer you're getting here, if you just multiply that by 100, that'll switch it back into an actual percent. You would round because it was 3251. 1 was the next digit. Yes. Yep. What are we talking? Oh, are you guys talking about Scrooge McDuck? That'd be his coins. I don't know why they're not gold. They're just. Yeah. That's really weird. That's weird. Interesting. All right, guys. Last one. Barbara deposits $3,000 in a one-year CD at 4.1% interest compounded daily. What is the APY to the nearest hundredth? Go ahead and try this one on your own, guys. All right, guys. Plugging in your info should look like that. So your calculator gives you 0.041897, blah, 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 other stuff. If I want to actually write that as a percentage, and it wants a nearest hundredth, that means 2 spots. So moving that 2 spots, it's going to be 4 point, oh, I forgot a digit, and there was a 4 there. So it'd be 1/8%. Again, if you're not sure that when you get this big long decimal in here, just multiply by 100. And it'll switch it for you. Okay, if you struggle with that, just multiply by 100. Luke, what's going on?